we shall discuss about the reactions involving cleavage of COH bond. Here, the bond between C and O will be broken down. Okay. The examples are formation of acid anhydrides, formation of acid halides, formation of esters, formation of amines. Dear students, keep in mind that in the preparation of the carboxylic acids, we have observed the preparation of carboxylic acids from acid anhydrides, acid halides, from esters. These three can be converted into carboxylic acid. Carboxylic acid can be converted into these three. Here, we can also convert the amides to carboxylic acids. Okay, carboxylic acids to amides. Okay, that is why I already told you that in the organic chemistry we can convert any compound to any compound, and we can reverse that also by using suitable reagents. Okay, you have to practice a lot on these things. You have to remember the functions of the reagents. It is most required. Okay, yes, let's go with this. The first one, formation of acid anhydrides. Okay, formation of acid anhydrides. How we are going to convert the carboxylic acids to acid anhydrides? It is very simple. Using mineral acid like H2SO4 or alumina or phosphorus pentoxide, upon heating also. Okay, we can make use of using H2SO4 or alumina Al2O3 or phosphorus pentoxide or on heating Okay, we can easily convert the carboxylic acids to acid anhydrides. Anhydride is a lumps of water molecule from the acid. Okay, let us. I will show you how that. I am going to give you a general reaction equation. Take the carboxylic acid. Take one more carboxylic acid like this. Okay. Now treat these two with an acid and heat. What happens? H2O will come out. Here, in one case, you will see the cleavage of OH bond. In the other case, you will see the cleavage of CO bond. Here we are talking about reactions involving cleavage of CO bond. Okay, that you can observe here, CO bond. Along with this, in the formation of anhydrides, you can also see the cleavage of OH bond. Okay, this OH minus will join with the H plus and give the H2O acid byproduct. And what is the remaining thing? RCO. Okay. O. Then what is this? RCO. These will join together. Now this is called as, this is a carboxylic acid. No? These two are carboxylic acids. Okay. 2 moles of carboxylic acids are converted into 1 mole of acid anhydride. So what is anhydride? A loss of water or no H2O. Okay. From where it is obtained? From the carboxylic acid. Here just we are writing acid anhydride. And you can take here R may be equal to alkyl group or aryl group. Alkyl or aryl group. If alkyl group is CH3, acetic acid will be present, and that corresponding the anhydride is called as acetic anhydride. We can convert the acetic acid to the acetic anhydride, benzoic acid to the benzoic anhydride. Okay, Enjoy 100. Take the homework. Solve the reaction equation by putting R is equal to CH3 and R is equal to C6H5. Solve the reaction equation by putting R is equal to CH3 one time, give the reaction equation, and later in one more reaction, if you consider this as first one and take this as second one and solve this. Okay, it will be easy. Okay, this is all about the formation of acid anhydrides from the carboxylic acids. Now we shall go for the formation of acid halides. Okay, now we shall discuss about the formation of acid halides. Formation of acid halides. Here particularly we are taking the chlorides. Okay, we can convert the carboxylic acids to acid chlorides by using three different reagents. Okay, for example, take the carboxylic acid. This is a carboxylic acid, and treat this with phosphorus trichloride. Phosphorus trichloride. Okay, you can see the replacement of this OH by Cl. How many Cl are there? The Cl are there 3. So take 3 moles of carboxylic acid. Now you can get 3 moles of acid fluoride. 3 moles of acid. What will be the byproduct? OH is coming out now. OH is replaced with the Cl. So 3 OH is coming out. So that will be POH 3 times. This POH 3 times is nothing but H3PO3 is nothing but H3PO3. It is called as phosphorus acid. It is called as phosphorus acid. It is called as phosphorus acid. Okay. If here R will be an alkyl group or aryl group, no problem. Okay. Take one more reagent. Take carboxylic acid and treat with the PCl5. Treat with the phosphorus pentachloride. What happens? One OH will be replaced with one Cl. Okay, you will get it. RCOCl. Okay, plus what is left? This hydrogen will combine with one Cl. You will get HCl, and remaining is one oxygen and this P 3 Cl. So you will get PO4. This is called as phosphorus oxychloride. Phosphorus oxychloride. Phosphorus oxychloride. Look at the difference. When you use PCl3, it requires 3 moles of the carboxylic acid and it gives phosphorus acid as the byproduct. When you use PCl5, it requires only 1 mole of the carboxylic acid and it gives HCl and phosphorus oxychloride as the byproducts. You need to remember the formation of the byproducts also in these cases. Okay. We have another method called as Darjan's method. Where you are going to use the thionyl chloride. Okay. Take the carboxylic acid and treat with SOCl2. What is this SOCl2 called? Sulfurous oxychloride. Sulfurous oxychloride or simply thionyl chloride. Or simply thionyl chloride. When carboxylic acids are treated with the thionyl chloride, you will get RCOCl plus SO2 plus HCl plus HCl. This is a best method to convert the carboxylic acids to the acid halides. Here it is particularly acid fluoride. Darton's method is a best method to convert the carboxylic acids to acid fluoride, since the byproducts are gases and it is easy to purify. Okay, because the byproducts, because the formed byproducts are gases and easy to purify the product and easy to purify the product. Why the Darton's method is the best method to convert the carboxylic acid to the acid fluoride? Because the byproducts are gases and easy to purify the product. In case of this, HCl is a gas, but phosphorus oxychloride is there, no? Okay, and here it is a liquid. It is a liquid. It is a gas. Here you need to purify a product after formation. If you want to purify this, you have to remove this. It is a liquid. You have to go for a separate technique. If you want to purify this, you need to remove this. This will go off, but because it is a gas. Okay. And if you want to purify this, these are escapable gases, and purification requires no much extra efforts and it is easy. That is why this is a preferable best method to convert the carboxylic acid to the acid fluorides. Here, in all these cases, you may take R is equal to alkyl or aryl group. R may be alkyl or aryl group. Okay. Yes. Now let us discuss about the conversion of the carboxylic acids to esters. This is already discussed one under the unit alcohols, phenols. When alcohols or phenols are treated with the carboxylic acids in the presence of an acid like H2SO4, it gives esters as the product. What I told you? When alcohol or phenol, means here you may take R as alkyl or aryl. Aryl is benzene ring. Okay, this is also called as phenyl. Okay, it may be an alcohol or phenol. When you put R as alkyl groups, means CH3, C2H5 like that, it will be alcohol. When you take R as a benzene ring, that is C6H5, this will be a phenol. Okay. When alcohols or phenols are treated with the carboxylic acid, to make it simple, I am going to take this formula in the reverse way. Okay. What is this? Carboxylic acid. When alcohols or phenols are treated with the carboxylic acid in the presence of an acid, gives esters. What is the general formula of ester? RC double bond OR. Okay, and this will be accompanied with the release of H2O. I will show you that in the carboxylic acids, this CO bond breaks. We are discussing about that one only. Reactions involving cleavage of CO bond. Here CO bond in carboxylic acid is going to break. In the alcohol or phenol, this OH bond is going to break. About this, we have already discussed. In the alcohol or phenol, OH bond breaks. In the carboxylic acid, CO bond breaks during esterification. What is this called? This is called esterification reaction. This reaction is called as esterification. Okay, and this product is ester. What is esterification? The formation of esters by treating the alcohols or phenols with carboxylic acids in the presence of an acid. Okay, and this is a reverse reaction. After getting a carboxylic acid, you have to immediately remove the water molecule, or else it will react with this. Hydrolysis of ester takes place to give the carboxylic acid and the alcohol. Reverse reaction is possible. That is why you need to remove the water molecules after product formation. Okay. Here you may take R alkyl or aryl group. Here also R alkyl or aryl group. You need to make your own examples. Okay. And here, if suppose this is R, this is R dash, you will get RCOOR dash like this. Okay. Yes, this is about esterification. And the next one is formation of amides. The next one is formation of amides. Okay. In this case also, you will see the cleavage of CO bond. Cleavage of CO bond. Okay. Yes. Take down the general reaction equation. RC double bond OH. This is the general formula of the carboxylic acid. When this is treated with ammonia, okay, you are going to get ammonium carboxylate salt. RC double bond OO. This is an acid, this is a base. So what will be formed product? It will be a salt. When acid reacts with a base, you will get a salt. Which salt? Ammonium salt. You are going to get the ammonium salt. NH4 plus. This is NH4 plus. This is also minus. What is this called as? Ammonium carboxylate. This is called as ammonium carboxylate. Ammonium carboxylate. When it is further heated, what happens? H2O comes out. H2O comes out. If I write negative H2O, means it is release of H2O. It is release of H2O. Here negative sign implies H2O is coming out. H2O is coming out after heating. So what will be remaining? O is not there now. Na here 2 hydrogen NH2. So you will get RCONH2. This is called amide. This is called amide. Okay. Based on this, many times the questions are asked in the annual examinations. Okay. I will take some suitable examples here. Take acetic acid, CH3 COOH. This is called as acetic acid. When acetic acid is treated with ammonia, you will get ammonium acetate as the product. CH3 COO NH4. It is called as ammonium acetate. Ammonium acetate. Okay. And in the NCERT they have shown these are reversible reactions. So better to take that also. Okay. These are undergoing reverse also. Okay. If this is heated, what happens? It will form the corresponding amide, no? That is CH3 CONH2. What is this called? This is called acetamide. Acetamide, and you can see the formation of H2O also as byproduct. Here, acetic acid is converted to acetamide by heating with ammonia. Once in the examination, the question is asked like this: explain the action of ammonia on acetic acid. One of my old student has written ammonia is reacted with acetic acid to give ammonium acetate. Up to here only. He has not written the continuation. Okay, and he got 0 marks for that. When they ask for action of ammonia on this acid, you have to write the entire reaction up to amide formation. Then only you will get full marks. Okay. Next. When you take the aromatic carboxylic acid, such as the benzoic acid, what will be the product? Benzamide will be the product. When acetic acid is giving acetamide, benzoic acid will give benzamide as the product. When benzoic acid is treated with ammonia, you will get ammonium benzoate as the byproduct. Ammonium benzoate as the product. Here, instead of writing C double bond O like this, you can directly take COO, no problem. What is this called? Ammonium benzoate. Ammonium benzoate. When this is heated, obviously it will give the amide as the product. And byproduct is water. And byproduct is water. This is what? Benzamide. Okay. Now take one more aromatic dicarboxylic acid. What is the aromatic dicarboxylic acid? Phthalic acid. This is called as phthalic acid. Phthalic acid is the common name. IUPAC name is benzene 1,2 dicarboxylic acid. Okay. Yes. Now, when this is heated with ammonia, how many moles of ammonia you require? 2 carboxyl groups are there, no? That's why you require 2 moles of ammonia. Okay. Yes. 2 moles of ammonia is required. Okay. Now, what you will get when the benzoic acid and treating with ammonia gives ammonium benzoate. Now, phthalic acid and treating with ammonia, you will get ammonium phthalate as the product. That is COONH4. COONH4. This is unstable salt. Okay, this is called ammonium phthalate. Ammonium phthalate. See, this is unstable one and gives a product, that is phthalamide. Phthalamide you are going to get like this. What is this compound? Phthalamide. What is coming out? Here you can see 2 hydrogens with 1 oxygen, which you are going to get 2 moles of water as the byproduct. 2 moles of water as 1 mole of water from this, 1 mole of water from this. Okay, this is called as phthalamide. You have to carefully observe the spellings also. What is this? Phthalamide. Amide it is. Okay. Now, on further heating, what happens? If you consider this as heating, this is further heating. Okay, what happens here? It will give you phthalimide like this. What you are going to get? Talimide you are going to get. See, look at the spelling. It is talimide. Amide, A is there. It is talimide. I is there. Okay. What is coming out? One N, one hydrogen is there. This hydrogen is not there. NH3 is coming out as the byproduct. Ammonia is coming out as the byproduct. Here, when they ask you to explain the action of ammonia and phthalic acid, you need to write up to here. It is very simple also. How to give the explanation? It's very simple. When thalamide is treated with ammonia, gives ammonium thalate, on heating gives thalamide, on further heating gives thalamide and ammonia as the byproduct. The explanation is very easy. Okay, that's why you have to learn the organic chemistry step by step. See how we initiate or introduce the chapter. We will, for example, we take aldehydes, ketones, and carboxylic acid. In first case, we will give some basic information about these compounds. Then we will give how to give the common names and the IUPAC name. Next, we shall go for structure of these groups. Then preparation methods. In all these cases, we are going to write the either common names or IUPAC names of the compounds. See, here the reactant is acetic acid. I am writing that intermediate is this and product is this. Every time we are going to write the compound names under its formula. See, in all these cases, it looks very nice also. And this type of writing the reaction equation is called as self-explanatory equations. No additional explanation is required for this. But also, in my notes, I write the self-explanatory equation and also the explanation. Because, however, we are going to give the correct answers and write it in 2 sentences. It will fetch you good impression and good marks. That is the success point of a student. Okay, so keep in mind in these things. Okay, learn properly what is the common name, what is the IUPAC name of the compounds, how to write the chemical reactions. Chemistry is very easy when you understand the basics. Okay, yes, we shall go for the next type of the reaction. Dear students, let us take this topic, reactions involving COOH or carboxyl group. Okay. Here, the reagent is going to act on this carboxyl group. Let us take the examples. The first one is reduction of that carboxyl group, decarboxylation of that, and COOH electrolysis. These three involve the action on the carboxyl. Okay, let us go one by one. Okay. Reduction of carboxylic acids will give the primary alcohols. Reduction of carboxylic acids gives primary alcohols as the product. Primary alcohols as the product. For this, we are going to make use of diborane or lithium aluminium hydride. These are the strong reducing agents, and followed by hydrolysis will give the primary alcohols. I will give you a simple reaction equation. The carboxylic acid is treated with In the first step, it is treated with lithium aluminum hydride, okay, or diborane, What is diborane? B2H6, B2H6, and followed by hydrolysis will give the primary alcohol. Will give the primary alcohol. Similarly, here you can take R is equal to alkyl or aryl group. Alkyl or aryl group. You can convert ethanoic acid to ethanol, benzoic acid to benzyl alcohol. I will show you that one equation. This is the benzoic acid. See, when you understand the basics properly, you can play with the reaction equations. Okay. When this benzoic acid is treated with lithium aluminum hydride, or diborane, followed by the hydrolysis, you will get corresponding primary alcohol. This carbonyl group will be reduced to alkyl or the hydrocarbon part. So you will get CH2OH. That OH part is as it is. This oxygen is replaced with the two hydrogens. This is called reduction. This is called as now benzyl alcohol. It is the common name. Then what is the IUPAC name? 1-phenyl methanol is the IUPAC name. Okay. About these things, that is nomenclature of the alcohols and phenols, we have discussed in that previous unit. Okay. So the reduction of the carboxylic acids will give the primary alcohols. Okay. You have to solve more number of examples by replacing this R with the alkyl groups. Take CH3 and solve. If you put CH3 here also you get CH3. Ethanoic acid will be converted into ethanol. These are very simple. Okay. Next we shall go for decarboxylation. Now let us take decarboxylation. How it is done? Using soda lime. What is this soda lime? 3:1 ratio of sodium hydroxide and calcium oxide. Okay. Calcium oxide is also called as quicklime. Okay. Let us see with a general equation. RCOO here the different thing is that we are going to take the salt of carboxylic acid, not the carboxylic acid. Here we are going to take the sodium carboxylate. How to get this sodium carboxylate? It's very simple. Treat the carboxylic acid with sodium metal, or treating the carboxylic acid with the sodium hydroxide, or treat the carboxylic acid with a weak basis like sodium bicarbonate or sodium carbonate will give you the sodium salt of carboxylic acid. It is also called as sodium carboxylate. When this is treated with soda lime, here, why I am writing the NaOH here and CaO here? Here CaO is acting as a catalyst. Okay, NaOH is undergoing the chemical reaction, but we use this mixture together. Okay, what happens? Decarboxylation means COO group will come out. Okay, how? Na2 CO3 will come out. Na2CO3 will come out. What is left? R with hydrogen. You will get RH. So what is called hydrocarbon? You are going to get the hydrocarbon as the product. And what is the byproduct? Sodium carbonate. Sodium carbonate. The removal of carboxyl group is called as decarboxylation. This can be achieved by treating the carboxylic acids with the soda lime. Okay, and here you can convert the sodium benzoate to benzene also, and sodium ethanoate to the methane also. Here, what is happening? One carbon is becoming less in the product. In the product, you can see one carbon will be less. I will show you how. Take the examples. Take CH3COONA. This is called as sodium ethanoate. And treat this with soda lime. Okay. What happens? Decarboxylation. Na2CO3 comes out. What is left? CH3H is nothing but CH4, methane, plus Na2CO3. You started with yet 2 carbons, but the product is with 1 carbon. Means in decarboxylation, 1 carbon will be removed from this structure. Okay. Yes. If you take sodium benzoate, you will get a benzene as the product. You will get the benzene as the product that you try at home. Okay. Yes. You can also take R is equal to alkyl R aryl group here. Okay. R is equal to alkyl R aryl group. And solve the equation for sodium benzoate. Okay. Let us discuss about COOH electrolysis. In the first PUC also you have discussed about this COOH electrolysis under the unit hydrocarbons. Okay. It is also involving decarboxylation. It is also involving decarboxylation. Okay. Electrolysis means lysis is a breaking of a bond due to passing electricity to the mixture. I will show you that. Okay. Take the carboxylic acids. Here we put 2 moles of carboxylic acid. For example, it may be a liquid or a solid. Okay. It will be made to dissolve in water. It will be made to dissolve in water. Okay. And electrolysis, that is passing electricity, will be made. Upon passing electricity to this solution, aqueous medium, what happens? This carboxyl group will come out as CO2, carbon dioxide. How many carboxyl groups are there? 2, no? So you will get 2 CO2 will come out. Okay. And here you are going to get the R will combine with R. Actually, it follows a free radical mechanism. It follows a free radical mechanism. It follows a free radical mechanism. R will combine with R. R will combine with R. So you will get a higher hydrocarbon. You will get a higher hydrocarbon. And here, make it RCOONA, for example, sodium salt of carboxylic acid. Sodium salt of carboxylic acid. Okay. Take sodium carboxylate. How many sodium ions you have? 2 moles. So therefore you will get 2 moles of NaOH. 2 moles of NaOH. Then what will be left? 2 Na over 2 CO2 over 2 R over, and from this 2 Na is combined with 2 OH. No? a hydrogen gas. You will get a hydrogen gas. So what is COOH electrolysis? When sodium salts of carboxylic acids are made to dissolve in water and that solution is electrolyzed, you will get a higher hydrocarbon through free radical mechanism. Actually, this compound will undergo breaking step by step. Homolytic cleavage of a covalent bond will be followed. That results in formation of free radical. The detailed mechanism is there and studied in first PUC. Okay, and here you may take R as alkyl group, but not aryl group. But not aryl group. This is very important point. Okay, the COOH electrolysis is applicable only for the aliphatic carboxylic acids. Aliphatic carboxylic acids. Not for aromatic. Not for aromatic. Okay. Yes. This is all about the reactions involving carboxyl group. Dear students, now let us discuss about substitution reactions in hydrocarbon part. Okay, here let us consider alpha halogenation. This is discovered by three scientists, Hell, Vallard, Zelinsky. That is why it is named by their names, and it is called as HVZ reaction or Hell-Vallard-Zelinsky reaction. Let us understand what is this. The carboxylic acids with alpha hydrogen will undergo this. Okay. What is the necessary condition? That is what we have discussed in aldol condensation reactions. Now, which type of carbonyl compounds will undergo aldol condensation? The compound with the alpha hydrogen. Similarly, the carboxylic acid with the alpha hydrogen will undergo this reaction. Okay, it is a distinguishing test also. Okay, take the carboxylic acid. Okay, this is the carboxylic acid. Okay, having the alpha hydrogen, where R is equal to alkyl aryl. Okay, alkyl aryl. See, this is not aromatic. This aliphatic carboxylic acid. Aliphatic carboxylic acid with alpha hydrogen. You have to remember this. Which type of carboxylic acids will undergo HHN reaction? Aliphatic carboxylic acids. Aliphatic carboxylic acids with alpha hydrogen. When treated with in first step X2 means halogen, where X is chlorine or bromine only, in the presence of red phosphorus, followed by the hydrolysis, you can see that one of the alpha hydrogen will be replaced with the X, that is halogen. Remaining remains as it is. Replacement of hydrogen with the halogen is called as halogenation. This takes place at alpha positions. Therefore, it is called as alpha halogenation. It is discovered by these three scientists. Okay. Yes. Where X is equal to halogen, CNR bromine only. Okay. Here, very important thing is, note, formic acid and benzoic acid cannot show this test. Formic acid, benzoic acid. Formic acid and benzoic acid cannot show HVZ reaction. Cannot show HVZ reaction because of absence of alpha hydrogen because of absence of alpha hydrogen. Ethanoic acid shows this test. Ethanoic acid, that is CH3COOH. It has ethanol. It is what? Ethanoic acid. It has alpha hydrogen. Therefore, undergo HV reaction. Okay. It undergo ethanoic acid has alpha hydrogen. Therefore, undergo HV reaction. Okay. You can solve that. Okay. Here R may be alkyl, or aryl group, or hydrogen. When that R is hydrogen, it will be a CH3COH. No? Okay. So, in the organic chemistry, you need to remember a lot, you have to practice a lot. But these are very simple and easy. Okay, you can write the reaction equation for acetic acid, propanoic acid, butanoic acid, even benzylic acid also. Benzylic acid means in this R you take C6H5, that is benzene ring. Benzylic acid. Yes. Dear students, now let us engage the topic electrophilic substitution in the aromatic part. Usually the electrophilic substitution takes place in the benzene ring. Okay, that's why you have to take aromatic carboxylic acids. Aromatic carboxylic acids. Okay. Take the aromatic carboxylic acids and these undergo the nitration reaction, okay, and the halogenation reactions, but not the Friedel-Crafts reactions, not the Friedel-Crafts reactions. Okay, let us engage the nitration of benzoic acid. Nitration of benzoic acid. Here, the benzoic acid, where carboxyl group is meta-directing, carboxyl group is deactivating group, electron withdrawing group. There are many names, okay, based on its properties. It is an electron withdrawing group. Electron withdrawing group. Carboxyl group directs the incoming electrophile. Carboxyl group is electron withdrawing group. It directs the incoming electrophile to meta position on the benzene ring. Why it directs the incoming electrophile towards meta position? Because it is electron withdrawing group and deactivates the benzene ring at ortho and para positions. Now the meta position will be the only electron rich option for the attack of the electrophile. Okay? Yes. Take the benzoic acid. This is what? Benzoic acid. When it is treated with a nitrating mixture, that is mixture of concentrated nitric acid and concentrated sulfuric acid, will generate the electrophile NO2 plus ion, that is called nitronium ion. Now you can see the meta-nitrobenzoic acid. Meta-nitrobenzoic acid. Meta is the system used in the common names. Okay. For 1, 3 positions it is called as meta. So it is meta-nitrobenzoic acid, and here the byproduct will be H2O. It is an electrophilic substitution. Here, the hydrogen present at the meta position is replaced with the another electrophile NO2. Here, the electrophile is NO2 plus O2 plus. It is the electrophilic substitution of benzoic acid or nitration of benzoic acid. Okay. Dear students, the last reaction in this carboxylic acids part is bromination of benzoic acid. You know that carboxyl group is electron withdrawing and directly incoming electrophile towards beta position on the benzene group. Okay. To conduct a bromination, we need bromine and the Lewis catalyst, Lewis acid, FeBr3, and it also acts as a catalyst. Okay. Here, the attack of bromonium ion, this is the electrophile generated after these two react. Okay. Bromonium ion, that is Br plus ion, replaces the H plus ion of this benzoic acid, and you will get the meta-bromobenzoic acid like this. How to give the explanation? When the benzoic acid is treated with the bromine in presence of iron bromide as a catalyst, will give the meta-bromobenzoic acid as the product. Okay, so this is all about, and here the byproduct will be this, one of the Br minus will combine with the hydrogen now, so you will get HBr as the byproduct. HBr as the byproduct. Okay, so this is all about the chemical reactions of the carboxylic acids. Now we need to discuss about uses of carboxylic acids. Uses of carboxylic acids. Here we have to discuss about uses of formic acid. Okay. Uses of acetic acid. Then uses of benzoic acid, and here the very important one is sodium benzoate. Sodium benzoate. Here we need to discuss about the uses of these. Formic acid, you know, it is available in red ants and these honeybee. When red ant or honeybee injects, that will having this acid, that is why irritation will occur. That is why it is called as formic acid. Okay, that is the source of the formic acid. And this formic acid, when reduced, will give methyl alcohol. Okay, the formic acid can be converted into formaldehyde. Formaldehyde has many uses, you know that already. Formic acid can be converted into corresponding alcohol, that is methyl alcohol. It is also called as wood spirit. It has many uses again. And acetic acid is a very important compound. It also can be converted into the corresponding aldehyde, acetaldehyde. On reduction, on further reduction, it can be converted into the ethyl alcohol. You know the importance of the ethyl alcohol also. Other than these, formic acid and acetic acid are having many other uses. Please refer the NCERT book for that. And benzoic acid can be converted into the sodium benzoate. Now the sodium benzoate is used as a food preservative. This is used as a food preservative for ketchups, it is used as food preservative for ketchups and juices. Ketchups and juice. To store the ketchups and juices for a long time, we will add sodium benzoate to that, so that this spoiling will be reduced and can be maintained as fresh for a long time. That is why sodium benzoate is used as a food preservative. This is very important and is asked many times in theory as well as competitive examinations. Okay. Other than these, you refer the NCERT or any other books for more uses. Okay, next. See, what are all the topics I have discussed in the classroom? Those are all based on the NCERT. Okay, and here somewhere I will be giving some extra points other than the NCERT also. Okay, make a list of those points, important points. Okay, and kindly refer NCERT, my class notes. First you need to refer NCERT book, my class notes which I have gave it to you. Then also refer some other private author books like MTG or Dinesh or Singlish, Errorless, to gain more knowledge. And you better prefer one book which is having the complete information and solve the MCQs given after that unit. You need to practice every day to memorize these reactions. Okay, so this is the end of the chapter. We shall see with a new unit. Okay, thank you.